Okay, so this is the deal. Okay, so uh, we have total 12 units in Khan Academy for digital literacy prep. That covers the entire syllabus for this digital literacy. Uh, I know everybody in this group has enough time to prepare for SAT, so we're not trying to rush and finish that syllabus. Okay, so what we'll do is we'll keep on going in sequence, like what I mentioned today. We'll start from unit 1 and keep moving towards unit 12. But since you guys have your school starting soon, right? So if there is any topic that comes up in the school, also say, okay, fine, this is something that is being taught, I want to cover this one before. So just let me know a couple of days in advance so that we can plan to pause that flow of digital SAT preparation and then cover that topic and then again go back to SAT. So that way you are keeping pace with your school and you are also preparing for SAT in parallel. Will that be okay? Yeah. So only thing is make sure that you inform me a couple of days in advance. Okay, fine. This weekend, sir, could you please cover this topic? And it's not only for one person. I mean, right now I've given a lot of priority to Isha because she has her exam coming up soon. But then once Isha is done with her exam, then everybody will have that flexibility of asking for certain topic to be covered. And just let me know a day or two in advance so that I'll make sure that I cover the entire length and breadth of that particular topic. Okay. So with that being said, I'm assuming that nobody is having any priority for me for this weekend or for today. So they will start from fresh with a digital SAT preparation. Okay? So it's like whatever we have done so far, we are putting a pause to it now because unit 12 is kind of done. At least we have done one round of unit 12. Now we are starting with unit 1, which is basic algebra. That's what we are starting with, and you will not find a lot of new concepts in that one because many of the things that we have covered is going to be, we'll be repeating them as well. So if you look at the topics that we have in this first unit, it is solving linear equation with one variable, linear equation with two variables, different types of solution techniques, then solving for linear inequalities. So we'll look at what are those inequalities and how do we deal with them, how do we interpret them and how do we use them in solving problems. And then what are different types of linear inequalities, and then creating equations with no solution and infinite number of solutions. So if we cover this covers the first lesson of unit 1. And we'll try to go as fast as we can because a lot of things will be very easy for you guys, okay? Because we have covered that in the past. So let's start with linear equation with one variable and two variables, and let's look at how much do we know versus what we need to know. Okay? So that way we can cover these things faster, and then we can put a focus on things that needs more rigor from our side. Okay? So linear equations. Again, going back to basics. What is a linear equation?
So the equation that has the power of 1.
Say again louder, Vaibhav.
The equation and the degree is equal to 1.
That is one way of representing it. Okay, what else?
And it has a steep line.
I would not agree to that. Oh, you said steep line or you said straight line?
Straight line.
A straight line. Okay, then I will agree. Okay. What else? Maximum power 1, that's what Vaibhav was saying as well. So maximum power, when you say maximum power 1, now let's try being more explicit here. When you say maximum power 1, meaning the maximum power to the variables. So if I am talking about an equation in the form of y equals to ax plus b. Here, these are constants, okay? Let me not put a and b so to get you guys confused. Let's say 5x plus 7. Here the variables are x and y. The maximum power to them is 1. Or the exponent is 1. Maximum is 1. Here you can say this is 7x to the power 0. Yep. Because anything to the power 0 gives you a 1. So maximum power to the variable is 1. And second thing is, a linear equation is an equation which helps you form a straight line. Very simple. Now, you guys have played with it, okay? I mean, there is nothing surprising that is going to come your way when it comes to linear equation. But what we'll focus on today is using some tricks for solving the linear equations faster, or going back to the basics and recalling some of the key techniques that we need to be aware of to be able to solve the linear equations faster. Let's look at one equation. When you see a linear equation, first thing that should come to your mind is, look at how many variables you are dealing with. It's one equation and you have only one variable. When you have one equation and one variable, you'll be able to solve it with ease. Not a problem at all. Now I would want you guys to keep on playing with this kind of equation. Now you have an equation like this. If you have to solve it for x, what will you do? Bring all the similar type of things on one side and one side of equal to sign, and other similar things on the other side of equal to sign. Here, what are the similar things? This is one term with a variable and these are constants. Yeah? What do I mean by bringing similar things together? Meaning all the constants you can bring on one side. All the terms with variables you can keep on one side. So what you will do, you will keep 5x on one side of equal to sign, and everything else goes to other side of equal to sign. It goes from here to here. What does it become? Minus 7. Plus becomes minus, minus becomes plus when you make it traverse across equal to sign. Multiplication becomes division, division becomes multiplication if you make it traverse across equal to sign. So this is like we're just playing it. It's a game. We're not learning now. This is 13. So if you look at what I'm doing, I'm just going step by step. This is what I had. Next step I will define. So that means 5x equals 20 minus 7. Meaning I made it travel from here to here. And hence 5x equals 30. And hence now it is 5x, meaning 5 into x. Yeah? Is 13. Now it is, again, our objective is always to keep similar things on one side. Now if you look at this equation, you have one variable and this is a constant, this is a constant. What we are trying to do is we are trying to solve it for x. Meaning I would want x to be on one side of equal to sign. And then I will say x equals something. That's what we are trying to get to. Right? So now I am trying to keep x on this side. What does it mean? It's a multiplication. If I am making this guy travel across this side, multiplication becomes division. So if this guy goes from first floor to the basement, yeah, 13 by 5. So again, these things are, you guys are not going to appreciate much. I know you guys know much more than this. But I'm saying for the sake of simplicity, whenever you're solving a linear equation, this is what you do. And nothing new I've taught you there. But what will be your takeaway? If I'm trying to solve a linear equation with one variable, then one equation is sufficient. Like we had one equation with one variable. Without anybody else's help, we could solve it for us. Imagine a linear equation which says 3x plus 6y equals to 10. This is a linear equation. because maximum power to the variable is 1. Can you solve it? You cannot. The rule of thumb is you would need as many equations as you have number of variables here. If you have two variables x and y, you would need at least two equations. Now the second equation could be x plus 3 equal to 17, or it could be x plus 3y equal to 17. Both are fine, but we need two equations at least. Okay? If this is the case, then also you are fine. You can find out the value of x from here, and you substitute the value of x in this equation to get the value of y. Net, the thumb rule is you would need the same number of equations as you have the number of variables to do it. If you have to solve it for two variables, you need two equations. If you solve it for three variables, you need at least three equations. You can have more, but you would need at least three. Here you have two variables, so you would need at least two equations. So far, any issue with whatever we have talked about? Vaibhav, Srivatsav, Dhanishri, Vishal, okay, all right. Now, let's play a little bit more. I have to solve 5x minus 3y equal to 20 and x plus 2y equals to 3. If you have to solve for this equation, what will you do? How will you start? How will you get started? I mean, don't try solving. Tell me the approach, the process, the thoughtfulness. How you want to approach this first?
Combining equations.
Sorry, say that again.
Combining equations.
Combining equations. Can you peel the onion for me a little bit? What do you mean by that?
Like, we just like choose one equation and like remove the common ones. Like, we keep like one variable and if there's any common on the other side, and we merge the answers.
Okay. So let me do it like a child, okay? And then tell me if I'm going the wrong direction, okay? I have two ways of solving this problem. Here, I see that I have one variable, in the second equation I see x plus something. Here, from this equation I can get the value of x. What will I do? My first approach, okay? I will find out x equals 3 minus 2y. I got everything else on the other side so that I can get the value of x here. Now what will I do? I will go to this equation and substitute x with this value. Now look at this. After we did this thing, this became a new equation for me where I have one equation with only one variable, y. Let's solve this. This becomes 15 minus 10y minus 3y equals 20. Yeah? This becomes 15 minus 10y minus 3y minus 13y equals 20. So now get all the constants on one side, all the variables on the other side. So I'm making 20 also come this side. 15 minus 20. This is plus, this is minus. Equals y to other side. Okay? Minus 30y becomes plus 30y. Okay? That means 5 minus 5 equals 30y. Or y equals minus 5 by 30. And then now I will substitute the value of y in any of the equation to get the corresponding value of x. This is one way of doing it. Yeah? This might take a little longer. There is a shortcut method also. What will you do? So, Athar, this is what you were saying, right?
Yes, sir.
Okay. Now, I am a very lazy guy, okay? I don't want to do hard work. I mean, that is not true, okay? I am a very hard working guy, to be honest. Today only I have done lawn mowing. Okay. Now, when I'm saying I'm a lazy guy, meaning I'm always in the lookout for finding out an easier or faster way of solving the math. What will I do here? See here this is x plus 2y. This is 5x minus 3y something. Let's do one thing. Can I multiply this by some number? Okay, let's multiply this guy by 3. So it becomes 6y. And multiply this whole thing by 2. So this also becomes 6y. And then I'll sum them up. So when I multiply this first equation by 2, what it becomes? 2 into 5x minus 2 into 3y equal to 20 into 2. Yeah? What is my second equation now? 3 into x plus 3 into 2, 6, 2 into 3y equals 3 into 3. So, 2 into 5, this became 10x. So, I'll write 10x. 2 into 3 became 6y. I'll write 6y. 20 into 2 became 40. Okay. 3 into x, 3, this is 3x. 2 into 3y, that is 6y. 3 into 9 into 3, oh, this is 3 into 3. So this became 9. Now what will I do? I'll add these two guys together. See, since I had one with a negative, one with a positive, I am adding them. If I would have looked at x here, right? If we had other option, we could have multiplied this by 5, this second by 5, and then subtract this minus this. So 5 and 5 would have gotten cancelled, and then we would have only had y. So let me now mix two things, okay? So now what we need, okay, fine. I have a y with a plus and minus. So how we can kind of cancel them out? So essentially what we did, we got the LCM for 3 and 2. That is 6. So now 2 multiplied by 3 gives me 6 and 3 multiplied by 2 gives me 6. That's why I'm multiplying these two equations by those numbers. Now let's add these two together. We're just adding them. So 10x plus 3x becomes 13x. Minus 6y plus 6y, 0. 0y. Or nothing. Equals 40 plus 9, 49. Now, instead of doing all that we were doing, in one step we got this. And this gives me x equals 49 by 13. Now you can put this value of x in any of the equation and find out the corresponding value of y. This was one option. This is what struck me. Now, I say, okay, I don't want to do plus. Do I have any other option? Now look at these two equations. Okay, how about, oh, this has 5x, this has 1x. If I multiply this equation by 5, I'll get 5x here also. And then I will subtract this, I will get this equation from this equation or vice versa, whatever we feel like. So, second option, okay, let me multiply this by 5. And this is already 5, so it's okay. So now I have second equation is 5x plus 5 into 2, 10y equals to 5 into 3, 15. So this is what my second equation has become. My first equation was this. Now, see, my objective is to simplify it. If I have two variables to deal with, I am trying to get to one variable. Because when I have one variable in an equation, my job becomes easier. So now, let's subtract. 5x minus 5x, done. Minus 3y minus 10y. Since I am subtracting it, so this becomes minus 10y. So this becomes minus 13y. Equals 20 minus 15, which is 5. Y equals 5 by 13. Yeah? So, whatever, we always had the option of solving, finding the value of x by one side and then substitute that value and then solve it. Or you have option of kind of doing this LCM way to find out, okay, how can I make one of the term match so that I can do subtraction or addition to simplify this equation for myself. Any questions so far?
No, sir.
No? Isha, Tharv, Shivatsav, Dhanushri?
Yes, sir.
No problem? No confusion? Pranit? Okay.
No, sir.
So we have looked at one option was we found out this value and then substituted, did that. Second is we multiplied both the equation with certain numbers to using LCM, and then we tried subtracting it or adding it to simplify this equation for us. There is a third way also. That is a graphical method. If I had equation like this, third method is I will just plot this graph, plot these linear equations. Okay? If this is 5x minus 3y equals to 20, this is my first equation. Okay? I'm just making it up. Okay? And this is my second equation, which says this. Wherever they meet, that is my solution. Meaning, whatever is my x and y coordinate, that's what becomes the value for x and y. Okay? So you can come across questions like say, okay, fine, here are the two equations, they are meeting at this point. Find out the x and y value for this one. So you can solve this equation, find it out, or just by looking at the graph, you can find the x and y coordinate, and that will be your answer for x and y, or value for x and y. So far, any doubt, any confusion? No?
Sir.
Yeah, brother. No doubt, no confusion.
Yeah.
Okay. So these are some of the very lightweight stuff, but this is where we tend to go wrong if you don't do enough practice. If you don't practice these sums, I mean, they will look very easy on the outlook, right? I mean, they will seem like, okay, this is like cakewalk. Why should I even worry about solving these sums? I know it already. But then my recommendation would be practice them enough so that way it becomes like a muscle memory for us. When I say muscle memory, I mean, what do I mean? When we talk, we don't think and talk, right? We don't think too much and talk, right? Because our muscles which are used for talking, they're already used to it, right? Let's say, I mean, you guys have American accent, I don't, right? I talk pretty much the Indian way. Because my muscles are tuned to the Indian way of speaking English. When you guys have spent enough time in school interacting with kids to adopt, right, the American accent, or maybe you have spent enough time here to be conversant with that accent. So that is part of the muscle memory. That's what I mean. So when, let's say, if I get an equation like this to solve, I will not think too much how to solve it, because I mean, as soon as I get this one right, I'll start solving for this. Oh, okay, x equals 3 minus 2y. I'm not even thinking plus because minus or whatever. This is like acting like a story for me. And then I'll say to find substitute this one, 5 into 3 minus 2y minus 3y equals to 10. So you will not actually struggle, or you'll have to think too much about it if you do enough practice. So that's what I would suggest. Make sure that you practice also. Do Khan Academy, try searching out for sample questions on internet, on Google. You'll find a lot of them. See if there's any question with whatever concept you have learned is actually making you struggle or not. Yeah? You make the questions struggle, or the questions will make you struggle. That's the deal. Yeah? So that's on the linear equation thing. Where we talked about linear equation with single variable, two variables. Similarly, if you want to make your life more complicated, you can go on talking about 3 variables, 4 variables also. So let's say somebody says 3x minus 2y minus 3s plus 4z equals to 70. Solve this. First thing you will do is 1, 2, 3, 4 variables. If I have 4 variables to solve it for, I need at least 4 equations. I would need 4 equations. First you get 4 equations. And then you will apply different techniques like what we have discussed so far. You can apply the same multiplication technique and then start knocking off other variables, or you can find out what to find. From this one I will find out the value of x. 3x equals 70 minus becomes 2y minus 3x becomes plus 3x, 4z becomes minus 4z. So x equals by 3. And then you substitute this value in the next equation and go on. So more the variables, more the calculation, and that's what it is. But thankfully for you guys, you will not have to deal with equations with more than 2 variables. Even if it comes down to 3 variables, that should be doable. But 99% likelihood, as per now whatever I have seen so far, I have not seen equations with more than 2 variables. Okay, so if you are able to solve with 2 variables, you should be good. But even if it comes down to 3 variables, don't freak out. Look at the equations with a cool head, and then you should be able to apply the same logic, same approach for solving it. I mean, just an example, okay? I mean, with 3 variables. Let's say if I have 3x minus 2y plus z equals to 20, 2x plus y minus z equals to 15, and 3y plus x minus z equals 12. If you have something like this, what you can do is you can do that in pairs. Look at these 2 pairs. This equation minus this equation. Okay? If you do this equation minus this equation, you can knock off z and you will get 1 equation. Similarly, this equation, this equation. Again, do the LCM and try knocking off 1 more variable. So then you will have 2 new pair of equations with 2 variables, and then you should be able to solve it, and then keep on substituting that value to solve it further. But be assured that you will not come across equation with problem with 3 equations. If at all you do, follow the same approach without getting stressed out. That's what I would say. Okay? Ultimately, it comes down to elimination. You are trying to figure out how do I eliminate one of the variables, make the equation simpler for me. How do I pick another pair of equation, again eliminate another variable, solve it for that. And then keep on substituting the value as soon as you find the value, so that you can find the other variables. Okay? But 99% you will not get equations with 3 variables, but if you still get, it is doable. Alright? Any questions with linear equation, single variable, 2 variables? No? Okay. Let's move on to the next topic. Next topic is solving linear inequalities. Now, who all remembers what is inequality? Inequality. What is inequality? Louder.
X is greater than or equal to 3, or
Okay.
something that's not exactly equal.
Uh-huh.
The variable can be more than this value, or
Yes. Okay. So I will even simplify that. Inequality means an expression or an equation where I don't have equal to sign. If I'm talking about an equation like this, this is equal to sign. If I change this to something like this, or greater than equal to, meaning it's not equal to, but it is still showing a relationship, or less than equal to. okay, or only less than. These are scenarios that is called inequality, meaning you have an equation but you don't have equal to sign. Okay. Now, how do you solve for this one? This one is nothing but plain and simple English, okay? And you guys know better English than I do, so it should be a cakewalk. Let's try look at how the question. Somebody says, let me give you a word problem. That let me talk on behalf of, let's say, Dhanushri, okay? And again, don't get me wrong, I'm just picking it up, okay? 2 times Dhanushri's age minus, okay, 4 times Dhanushri's age minus Dhanushri's dad's age is greater than 5. Okay? And I'm making it up, okay? I don't know how old is Raj, okay? So I'm just making it up. This is just a word problem. I'm saying 2 times Dhanushri's age, 4 times of Dhanushri's age is greater than minus her dad's age is greater than 5. What I don't know is Dhanushri's age. Neither I know Dhanushri's dad's age. Okay. But I just know that okay, whatever is Dhanushri's age today and whatever is her dad's age today, if I subtract 4 times of Dhanushri's age minus her dad's age, it will be greater than 5. Okay? So, this is just a word problem. When you are putting this in the equation, see, I said it's greater than 5. It's an inequality scenario. Okay? So, now let's say, or if you have other example, 5 times of x is greater than 25. What is the value of x? In case of inequality, you will not get an absolute value. It tells you a range. That's the main difference. When you say equal to, you are talking about absolute value. When you are talking about inequality, it tells you, it gives you a guidance saying these are the possible values. Now let's look at this one, this equation. 5x is greater than 25. What are the possible values of x? Let's first keep it simple. We'll deal with this exactly the way we deal with equal to, okay? Like how we solve a normal equation. If 5x is greater than 25, that means x will be greater than 25 divided by 5. Or x will be greater than 5. Okay? So what are the possible values of x? 6, 7, 8, 9, 10, and you can literally just go on. Okay? If the inequality was like this, is greater than or equal to 25, then I will have this also as one of the answers, and I'll just go on. So simple difference between inequality and normal equations is, inequality doesn't give you exact value or absolute value, it gives you a tentative range. It tells you what are the possible values. Let's say if I say that my salary is more than $3,000 a month. Okay, I know 3,000 is nothing in today's world, but let's say I'm just saying that. My salary is more than $3,000 a month. And I ask you guys to go on guessing about it. Somebody will say, okay, maybe sir is getting $3,001, or maybe he's getting $3,500, or maybe he's getting $7,000, maybe he is getting $18,000, maybe he's getting $1 million a month. Yeah. So there is no limit here. It just tells you what all you have to exclude and rest all is your value. So you are talking about a big number of answers. That is technically possible. That's what happens in the case of inequality. Now, okay, whatever I told you guys about my salary, none were right, so don't worry. I'm not getting 3,000, I'm not getting 1 million either. Alright, coming back to the inequality questions. Let's say somebody says 5x minus 25 is greater than equal to 6. Can you guys tell me 3 answers for this inequality? What are the possible values of x? I know this is a very simple one, but I just want to make sure that you guys get some time to play. So the question is 5x minus 25 is greater than or equal to 6. Give me 3 answers, 3 possible answers. Okay. So you guys solve it in a minute. I'll be back with my one more. Done? So, what are the possible answers for x? 7, 8, 9, 10. So, how about you guys? Anybody has a different point of view?
7, 8, 9.
Okay. So, it becomes 5x is greater than or equal to 6 plus 25. So, 5x becomes greater than or equal to 31. Or x becomes greater than or equal to 31 by 5. So 5, 6 is 6.2 and then onwards. So it includes 6.2 also. You can say greater than or equal to. Okay. So the problem that you will deal with here, they will not be very complicated. You just have to remain more vigilant about this sign. Okay? Is it equal to? Is it is it greater than? Is it less than? Greater than equal to? Less than equal to? Kind of thing. Okay? And there are 2 varieties of problems that you'll come across. One will be like word problem, where you have to frame the equation based on what is told in the sentence, and then solve it. Or second would be like normal equation that you have to solve it for. Now let's look at inequality problem with 2 variables. If you have 5x minus 2y greater than 7, or 3x plus y is less than 27, you will solve it exactly the same way. Okay? Like you solve any equation. Only thing that you have to be careful about is the interpretation part of it. Now let's look at this one. Okay, let's see how I'm solving this. So 5x minus 2y is greater than 7. Now what I'm trying to do is, let me get all the y on one side. So I'm making this guy travel this side. So 5x, I'm getting the constant this side. So 5x minus 7 is greater than 2y. Okay? Or you can write this as 2y is less than 5x minus 7. Yeah? The same thing. So see what happened. When I had a negative, this arrow flipped. When I am converting from positive to negative or negative to positive, this arrow flips and the meaning also changes. So here, this was my equation and now it became 2y is less than 5x minus 7, or y is less than 5x minus 7 divided by 2. So here, let's say if you are getting, let's say, a value of y for 1, 2, and let's say when x is, let's say 3. When x is 3, what is the value of y? When x is 3, y is 5x is 15 minus 7, 8 by 2 is 4. So y is less than 4. When x is 3, y is less than 4. So basically now when you look at the inequalities, right, it is going to be more based on the interpretation. Now you can look at the graph part of it. Okay, let's look at a graph. That will make it even more clear. Let's say my equation is x plus 3y minus 7 equals 0. Okay, I plot this. This is my equation. Now, if I am saying x plus 3y will be equal to 7 here. This is my equation. Now, the time I say x plus y is less than 7, which part of the graph we are talking about here? See, this is your borderline. When it was equal to, this was your line. Every point on this line was following this rule, x plus 3y equals to 7. Now you say x plus 3y is less than 7, meaning sum of all these values will be less than 7. If you are going in this direction, let's pick up x plus 3y is less than 7, right? So let's say I am taking x equals to 2. Okay? When this was my equation, okay, when x was 1, what was the value of y? Y was 2. Yeah? When x was 1, y was 2. That's the one right here. When x became, now in the same thing, when x is 1, then what is the value of y? When x is 1, 3y is less than 7 minus 1, or y is less than 6 by 2, 6 by 3, or y is less than 2. So we are talking about all the things below this one. When we are talking about less than, we are talking about all the values which is below this one. When we are talking about greater than 7, we are talking about all the things about this line. So, whenever you have to, let's say, they say, okay, fine, this is the inequality that you have to solve it for. Find out which side of the graph is representing this inequality. You plot the graph for equal to scenario, and then you look at some sample values and see which one is fitting the bill. Okay? And then you can choose which side it will be. This graph was probably not right for representing this one. That's why there might be creating some confusion. So first thing is, look at the graph, solve it for equal to, and then substitute some value with inequality and see which side is matching that condition actually. And then you'll be able to plot, you'll be able to identify which side of the graph is actually showing me the answers. Okay? So we looked at inequality, we looked at what is the meaning of inequality, what is it, how do we interpret that. Then we also looked at how do we plot that graph and try to find out which side of the graph is actually representing this inequality. Okay? So this is all based on interpretation. Again, with inequality you will not get a lot of questions for solving for x and y. You will have to just look at the condition. Just be careful with this condition. Okay? A very simple example would be, okay, y is greater than minus 7. With the normal human eyes, right? You say, okay, y is greater than minus 7, so we are talking about y equal to minus 8, minus 9, minus 10. And that is not correct. Because you are saying y is greater than minus 7, so it will be actually minus 6, minus 4, and all that. Okay? So we are going in the negative direction. No. Y is greater than minus 7. Yeah. So yeah. Minus 6, minus 5, minus 4, and you can go on the positive direction. So just see, even I started doubting myself, right? That when you are dealing with a plus minus sign and then you have inequality, you have to just keep your head in control, look at some examples and then verify it and then solve it. It will not be mathematically difficult one, but it will be mentally draining a little bit at times. Okay? So you have to just look at it with some examples and then verify it so that you don't go wrong with your interpretation. Okay? Any questions so far? Now? Dhanushree, Isha, everybody is quiet. I'm teaching everybody something that you guys have learned probably many years ago. But this is part of the syllabus, so that's why it is my job to kind of cover the entire syllabus. That's why I'm just doing a recap. And in a way, it helps you do a revision of what you already know. There could be some things that you might have learned and then you might not have kind of come across recently. So that's why it will help you kind of get it back. Okay. So now, there's one more thing. So, more of an announcement, okay? So, kids who are in DFW area, okay? I know, Vaibhav, are you in?
Sir, I'm near to DFW.
Sorry?
I'm near to DFW.
You are near to DFW, okay? So you are in Dallas area only. So basically, all the kids who are in DFW area, I would start scheduling a monthly test. Meaning, out of the 8 classes we are having every month, there will be one class which will be like an in-person classroom test. So kids who can travel to the class, okay, once in a month. I would want you guys to come over. We will just pick up any pre-SAT sample question paper and try solving it and see how much we are getting. Where are we getting stuck? So we have not covered the entire syllabus yet. We have just covered few units, right? Like unit 12, and then we are doing unit 1 right now. So maybe we'll do the test in the month of September. By then we might have covered one more unit. So just with the 3 units, how much we are able to score? Because a lot of things you guys have already learned in the past. So we'll see how much we are able to score. Then again next month we'll learn some more units and then again do the test and see how much we are able to score, where we are getting stuck, what are the topics which are easy or not easy, okay? And then again keep on repeating the same exercise next month. So basically, after 5-6 months, 2 things will happen. One is you will keep on learning and then you will check whether whatever you have learned, are you able to solve the problems with ease or not? Are you getting stuck anywhere? Is there any concept that we learn but we are not sure about it? Yeah. So that's why that's what I'm planning actually. So probably from beginning of September is what I'm planning. So in the month of August we'll try covering some more chapters, some more units, and then we'll do the test to see whatever I'm teaching you guys, am I able to make it simple, easy for you guys to be able to solve the problems with ease or not. And wherever we get stuck, either there is a feedback for the teacher to teach something little better, or there could be a feedback for my students to practice things a little more. Okay? So that way, when we do it more, when we kind of beat the drum again and again, when you actually go for the city exam, it will look like something that you have seen enough. Yeah? Because my goal is to get my students score a perfect 800 in SAT maths. Okay? That's my goal. If I can get to that, if some of you are able to score that, that is when I'll feel that okay, I'm successful as a teacher. Okay, so that's my goal, and that's what we'll work towards together. Okay, so that's why I'm trying to make you guys practice more, do homework, keep playing with that in Khan Academy, right? Like my own daughter, when I was teaching her, I realized that she was knowing that there is something in Khan Academy, but she had not practiced that enough. Similarly, Isha also probably, I'm not sure how much time you got to do Khan Academy, right? But this is one of the standard source of information for preparing for SAT. So if you play with that quite a lot, you'll be prepared ahead of time is what I'm thinking. So that's the goal. Let's see how soon we get tired with Khan Academy and all the concepts that we have here, and then we'll probably try finding out something more outside Khan Academy also. Okay? So next 1 year, let's kind of peel off each and everything that we have from a concept point of view for digital SAT in the Khan Academy, and then the subsequent year when you guys are actually getting ready for that, that is when we'll do a lot of practice in the class, You guys will compete with each other. You guys will ask questions, will practice, will play, have fun with those sums, so that SME exam becomes more like like a playground. That's the goal I have for you guys. Okay? So let's see how it goes. So I'm kind of trying to pause here. The reason being, Baba has to go and celebrate his dad's birthday, and please convey my best wishes. I have already wished him, but do it one more time from my side. Let me just check if there's something that we missed. Okay, now creating equation with no answers, no solution or infinite number of answers. Okay, this is a very easy one. I think I have taught this to Dhanushri and not to everybody else, because Dhanushri is the one with whom we have started this class much before, right? So, Dhanushri, would you remember how to treat the equation to get zero answer, zero solution or infinite number of solutions? Would you remember? Or let me do it quickly. This is a typical question that will come across. Okay? 5x minus plus 7y equals something plus 18. It will say fill something in the box that makes the equation with zero solution. Always look at knocking out the variable. If you knock out the variable, that equation will have no solution. Let's look at this. If I put a 5x here, what this equation becomes? I can knock out these two. 7 equal to 18. This is nothing but crap. Yep. This equation is not going to give me any solution actually. Instead, if I had 4x, then we would have solved it for x and we would have gotten some value. So as soon as you get the variable knocked off, that becomes a scenario when your equation has zero solution. Similarly, if you knock out the constant, you have equation like this. Okay? It says find out the scenario when you will have infinite number of solutions. And let's say this is 4x. No, this has to be same. Yeah, 5x. If you knock out the constant, or if you put 7 here, then this becomes 5x equals to 5x. This is like a universal truth. You can have x equals to 1, x equals to infinity, x equals 5,000, x equals 5 million, 20 gazillion, whatever you want to do. So, this is a scenario when you knock out the constant, that equation will become an equation which will have infinite number of solutions. If you knock out the variable, that is a situation that will make it an equation with zero solution. So that's the only thing that we wanted to learn in this chapter apart from what we have learned so far. So that brings us to the end of the class.